Listen-only mode.
Hi everyone, thanks for joining us for this session of Cambium College. Today our speaker is Bruce Collins. He's one of our directors of product management, and today he'll be talking about the industrial Internet of Things and how our radios, or radios in general, could help your network in that instance. As usual, we'll try to keep this interactive. If you have any questions, post them on the text box into the right, and we'll get to them throughout the presentation and again at the end if you have more. So without further ado, here's Bruce.
All right, thanks, and thanks everybody for joining. Today we're going to talk about the industrial Internet of Things, and there's a lot of messages and articles and news that you hear about Internet of Things, and so we're going to kind of talk about how does industrial Internet of Things fit into the overall Internet of Things. I'll give you some examples on how to determine whether it's regular old Internet of Things or IoT. Then we'll talk about lots of applications and talk just a bit about the technology that's used on the wireless side to basically make the Internet of Things happen. So again, fire away with any questions you have. This is fairly high-level material, but if you want to dig deeper into any topic, please feel free to chime in on the chat window. So again, the outline of the session today is what is the Internet of Things? How does IoT compare to IIoT? We'll talk about some examples in some various heavy industry, oil and gas, water, and rail. We'll talk about how does wireless communications fit in with IIoT. I'll give you kind of a IIoT reference model, which will help you decide where, when you're talking to a company or talking about a piece of technology or a product, how does it fit into the overall IoT? We'll talk a bit about how sensors tie together with radios and then feed that information back into the cloud for analysis and action. We'll talk about how does Cambium fit into all this, and then I've got some other references and resources to follow up if you want to learn more. So starting with the topic that you see almost every day in the news, if you pick up the newspaper, you'll see references to the Internet of Things. And what I'd like to kind of spend a minute or so on is when you hear about Internet of Things, people say, well, what is that exactly? And really the way I like to think about it is anytime you have an object that has some sensors on it, and that object now has connectivity to the Internet. So it's to contrast the Internet of people, which would be individuals doing email and connecting to web pages and watching videos. Internet of Things is a device with some sensors, and that device is feeding information back up to an engine that's going to do some a cloud-based engine that's going to do some analysis or analytics. So some examples of the Internet of Things that I've listed here on the left are smart cities. You might see smart parking. So if you pull into a parking lot and it says there's 17 spots on level 3, that's an example of the Internet of Things monitoring which spaces are open on that parking lot. And I find one that's pretty interesting is trash collection. You see trash cans now, I think they're called big mouth trash cans, and they have a trash compactor built into them that's solar powered. But then they also have a sensor in them that determines at what point does the trash can full, and it sends that status back to the depot, which will then say, what is the, that I'm ready to be picked up, or I'm ready to be emptied. So the people who are coordinating the routes for the garbage trucks can direct the traffic more efficiently. So you're saving money and you're making sure that trash cans aren't overflowing with trash. Autonomous self-driving cars, that's certainly a big area, Internet of Things. Smart homes, this is where you get closer to what people think about when they think about IoT. So you can see the pictures down below. You've got a thermostat that's connected to the Internet, appliances like a washing machine or a refrigerator, the Alexa or Echo from Amazon, and then certainly wearables, so things like the Apple Watch and the Fitbit, anything that you wear on your person that's, again, using sensors to connect to the cloud. But what we're going to talk about in this session is on the right-hand side, which is a subset of the IoT, which is really focused on the industrial Internet of Things. when we talk about the IoT, we're looking at things like the smart grid. This is for the electric utility system. So here we're looking at how do I reduce outages, how do I make the system run more efficiently, avoid brownouts or blackouts, and optimize the entire electric system. Things like oil pipelines, how do I predict if a pipe is about to rupture, or if it has ruptured, how do I quickly react to the leaks and prevent further damage to the environment. Railroad crossing safety, so positive train control is a big trend around the world. The ability to make sure that whenever there's grade level crossings and the trackside operations of a railroad is managed safely and efficiently. And then you also will read a lot about water safety and water quality in the press. And certainly the industrial Internet of Things can help with monitoring the quality, preventing flooding after storms, in monitoring and measuring the flow of water to consumers. So this kind of gives you some examples of how I would compare the IoT to the IIoT. And the rest of the session, we're going to really be focusing on the IIoT. I'll give you a couple of examples. Here is a water treatment process, and this is actually from a State of Utah webpage, but I thought it was a nice pictorial view of how water flows from a natural resource, here groundwater in a stream or a lake, flows through a number of filtration processes, then starts to flow through a series of chlorination, aeration, and pumping systems, and then ultimately is distributed to your home so that when you turn on your tap at home, you've got water flowing for your cooking or bathing or whatever you need in your home use. And so what I kind of want you to think about is that whole flow of water all the way from that pond all through these different systems, that there are a number of things that have to happen. One thing is I want to monitor the temperature, the pressure, the level of water in each of these areas. I want to monitor how much water is flowing through each of these areas. And then I also want to be able to turn on and off pumps in these areas so I can stop the flow or start the flow at any point in this process. So traditionally you might do that with a bunch of valves that you have to send somebody out to the field, turn the valve, take a look how is the flow working, turn those valves. And with the industrial Internet of Things, I can start to put sensors at every point in that whole process and start to not only take action to turn on and off pumps or look to see what the water levels are or the temperatures, but I can actually start to do some second order analytics where I'm actually looking at what are the impact and what are the sort of hidden signals that are in all of that raw data that's coming back from those sensors to kind of optimize and improve the entire system. So again, that's just one example in the water space. Here's another, this is a water space, kind of just a different view, but it gives you a sense of how these different systems are spread out across an area. You can see that river up at the top of the screen, and then the flow of water through the system as it leaves and goes out towards the consumers that are going to use that water. Similarly, the petrochemical industry, we talk about three aspects of oil and gas. We talk about upstream, which is the process of finding where to drill for oil and extracting that oil from using a drilling platform, whether it's onshore or offshore. It's prospecting, looking for oil in these far-flung areas. So you can see the pictures there, either out in the middle of a desert where you might find oil wells, or out offshore on a floating platform. Then there's a midstream, which you can see in the middle picture is pipelines, trucking, and storage of the crude material that's taken from the ground. And this could refer to either natural gas or oil, crude oil. And then you're going to pump it across these pipelines over very long distances and oftentimes in very remote areas. And then finally downstream, which is I'm going to take that crude oil, I'm going to refine it into the different products, whether it's plastics or gas for cars or other types of petrochemical products, and distribute that to customers. So again, if you think of that entire process from looking for oil, drilling it, passing it through the pipeline, refining it, and getting it off to the customer, you've got all a very similar set of issues where I'm going to be monitoring temperatures, pressures, flows. I'm going to be looking for how much material is going through a point at a given time, so measuring the flow level. And all of that needs to also not only be sensed, but controlled from a remote area. And then the last sort of high-level example is rail transportation. And here's an example. This is from the GAO showing positive train control. So when we look at the growth of the rail industry around the world, one of the key aspects is how do I increase the safety not only of passengers on the trains, but people that are crossing at grade level, actual material that's on these trains, and making sure that it doesn't, if there was to be an accident or a spill, it could have an impact on the environment. So you can see in the picture there, you've got, again, it's all about sensors. There's sensors along the track side. There's sensors in the train itself, and they're all connecting back to that dispatch system to understand exactly where that train is, what's the situation of the track out ahead of me, and what is the status of the different switches in the track out ahead. For example, you see there might be somebody working on the track, and you want to communicate that back to the train and stop it in time. So again, sensors all needing to talk back to a central location to optimize the system for efficiency and safety. So when we look at industrial IoT, we're really looking at these types of applications. The one I've just been talking about, you can also imagine each of those remote areas having a Wi-Fi hotspot so that the worker who's out in that area can get on the Wi-Fi and get back to their home office to check their email or look up blueprints or drawings, any information they might want to pull out of the internet or their corporate environment. You can also imagine video surveillance, having cameras in all those areas so that the security teams can monitor what's happening, not only to make sure things aren't being vandalized or stolen, but also to make sure that the people that are working in those areas are safe. And then there's also a whole bunch of infrastructure that's needed to connect point A to point B in all these networks. So we talk about that as a leased line or wireless, replacing wires with wireless, and also talking about metering and measuring the flow in all the different parts of these operations. And so what's common across all of these is really three things. One is they cover a wide geographic area. So they cover kilometers or hundreds of kilometers of area. There's hundreds or thousands of points that need to be connected. So if you remember those pictures of the water treatment facility or the oil and gas field, there's literally thousands or tens of thousands of sensors, perhaps thousands of nodes that all need to be connected back to a central place. And they need to be connected, what we say, confidently and confidentially, which really means reliably and securely. We want to make sure that these are protected from cyber attacks, which would be a fault condition that could be pretty disastrous in a mission-critical network. Is if somebody was to hack into one of these networks and start to fiddle with the electric grid or even the distribution of oil and gas. It's a pretty serious situation. So security is very important in the IIoT. So I'll give you a high-level reference model for the IIoT. When we look at this is kind of a generic reference that you can then fit in just about any of the pieces of technology or products that you might come across. And really the flow here is that I'm going to do data acquisition. That's where those sensors come into play. And those sensors, the job of a sensor is really to turn a physical situation like a level or a temperature or a pressure and turn that into a voltage or current. And then that voltage or current is measured with a to D converter and turned into a data packet that can then be transported across the network. So that moves into that transport area. And then once it's transported back to the cloud, the first level at the cloud is to take that information and normalize it, make sure it's all in the same format, and then publish it to all of the different potential users of that data. And that's where that last bar is, where it talks about analysis and decision making. That's the ability to take all that data and either take action by turning off a pump, turning on a pump, changing a switch, or looking at the data itself and trying to determine trends that might not be obvious to a casual human just looking at the macro data, but actually seeing at a very low level what are these signals that are coming out of the data that make sense to optimize the network. So you'll also hear a lot of references about the cloud as related to IoT or IIoT. So the cloud kind of sits over here on the right where we talk about normalizing and publishing that data, and then a bunch of different services can access that data via the cloud and pull that information down and start to take use of it. You'll also hear references to a smaller thing called fog. Fog computing, this is a relatively new topic, and this is actually moving some of that analysis out closer to the edge of the network. And that's important because you might have a situation where you want, let's say that train is getting close to a switch that's been opened and you want to stop that train quickly. That is some action or response that can be done very close to the situation. Doesn't need to go all the way back up to the cloud and then back down. That action can be taken right away, right at the edge of the network. And that's called fog computing. And then what Cambium really focuses on is this area called transport. And you'll see a whole long list of acronyms and buzzwords and technologies listed there. And the thing with Cambium is that we look at our role in this whole ecosystem as transporting data from the sensor that's out at the data acquisition layer and bringing it up to the cloud, which is that normalize and publish layer. And we are kind of agnostic about what technology we use. We have, you can see the ones with check marks are all different technologies that we have available within Cambium Networks portfolio. So you can think of things like broadband, licensed microwave, 802.11, some new SCADA products that do narrowband. And then that list will continue to grow as technologies emerge and become commonplace within this transport area. Cambium will be expanding our portfolio to align with the trends in the industry. But kind of think of Cambium as positioned in that transport area. And you know, we sometimes stretch a little bit into data acquisition. We sometimes stretch a little bit into the cloud. So it's not a perfect line, but it's definitely this is the area that of focus. And this is really the area of focus for wireless communications in the IIoT. This example shows how these different points might be connected in a IIoT or an oil field. So this starts to give you a little more of a visual on how that network could work. And what you see is those are transmitters with the little lightning bolts in between our wireless communications. And what I'm connecting up here is a bunch of sensors that are out in the field. You can see that tank battery has a water level, it has an oil level. I've got a flare that's burning off excess gas, and I've got a temperature sensor on it. All of these sensors, remember, are going to take that physical attribute, they're going to convert it to whether it's a voltage or a current or a threshold, and convert that to a packet and send it over the network. So it's going to traverse over one or more hops of the wireless network, and it's going to go back to a master server, and that server has the logic to determine what to do based on all that physical activity that's happening out in the oil field. And imagine this scaling up thousands of times over, so you have very large systems of radios interconnected. We won't go through this slide in a lot of detail, but I wanted to kind of give you a sense of how do you go right from that sensor back to the cloud. So starting with the sensor, which is here on the right, you can see everything from that dry contact switch. This is the simple fact of a door opening and closing, or a tank filling up to the top and now closing a switch when it gets to the top. You can also see at the bottom an example of a digital output. Here I'm going to turn on a motor, which could be a pump or an engine or a lift. So I can see, I can turn motors on and off, and I can read the status of different switches. And those go into our system on that I/O module pin. They go through that circuitry, and then you'll see that digital in and digital out on the left. And that's what the programmers are going to do when they look at an IIoT application. They're going to read inputs and they're going to write outputs, and all the way back from the cloud, and it's going to take that physical action on the schematic or on those sensors or actuators. Those sensors and actuators can be deployed in what we call point-to-point topology, or they can be deployed in a point-to-multipoint. And that point-to-point is simply I'm connecting point A to point B, and the point-to-multipoint I'm connecting a hub. Think of a hub of a wheel out to many different spokes. So I have one-to-many or point-to-multipoint. The other thing that's important in these systems is that then when all that data comes back up, you want to be able to manage what's happening. So this is a view of a management system from Cambium that is used to monitor the network itself. So I can make sure that that critical infrastructure network is operating, and I can pull information like, is everything working okay? How much data is flowing? Do I see an area that I need to increase the capacity? Because now people are requesting more information from a certain part of the network, and I want to be able to collect that information. Couple other real-world examples. This is a water management district in the state of Ohio in the U.S. And what you see in the middle of the diagram there, or the diagram, is a bunch of red dots. And those red dots each represent a radio, and each radio represents typically a lift station or a pump in that water treatment facility. So here I've got 33 radios. It's a combination of point-to-point and point-to-multipoint. So you can see in there some hub and spoke architecture, and you can see some point-to-point architecture. And so it's mixed and matched in that same environment. At each one of those red dots, you'll see in the upper left there's a building with that post sticking out the top. That's a Yagi antenna, and that's pointing back to a hub. Inside that building, there's a little cabinet, and you can see on the right here, that's where one of Cambium's radio, that blue radio sitting on the shelf, is a radio that's sitting in there. And so that radio is going to, again, connect to sensors and pass that data over the green bars back to the hub, and then take action back at the SCADA master. Here's another example. This is a water treatment or wastewater treatment application in Colorado, state of Colorado here in the U.S. The reason I want to show this one is if you look on the left, you'll see the antenna, which is that post sticking up in the middle, and that's actually pointing back over that hill past those buildings. So one of the things that's important is that when you talk about the industrial IoT, it's really, you're looking to connect the locations where these devices are. So you need to go find a way to connect where the machines are back to the cloud. So you don't always have the optimal site that you would pick to put a network. You have to bring the network to where the machines are. So oftentimes in the industrial IoT, finding a way to connect to these really remote areas where I don't have a true line of sight is one of the big challenges. And lastly, here's a well site automation. This is in the state of California. This is a example of one of those upstream devices we talked about, which is a pump jack. So this is an oil well that's been drilled, and now it's pumping. It's an active well. There's a whole bunch of sensors fitted on that pump jack. So I'm monitoring the amount of power that's being drawn. I'm monitoring the temperature, the pressure in each of the valves. And I'm looking to see, and remotely then I want to monitor, is everything working okay? Can I predict that it's going to need some repair? Do I need to send somebody out there to fix something before the entire pump fails? And then also, can I measure how much material am I pumping off of that well? And that way I can monitor how productive that field is on a given day. And you'll see that near that pump jack, there's that white box in the lower right, and it goes up to what I've called out there as a Yagi antenna. If you open up that white box, there's something in there called an RTU, or a remote terminal unit. This is one of those edge devices that can do some local control or management. So it's got a little bit of very, very, very crude fog computing, the ability to take some basic decisions out there at the edge of the network. And then if you were to open up that door you would see inside there one of Cambium's radios, a See and Reach module. And that radio is taking all of the outputs from that RTU, or all the sensors, and sending it over the air back to the cloud. So, and feel free to ask any questions if you like along the way here. There's a number of different potential customers or users when you talk about IIoT. So, the question becomes, well, who would actually buy an IIoT system, or who would actually need an IIoT system? And this kind of lists all the different users, and it's not an exhaustive list by any means. It's certainly a good starting point. So you can see the ones we've talked about, which are oil fields, electric utilities. Signage control is another one. If you're either in a remote area where I want to do traffic signage or advertising signage, maybe in an area that's remote and it doesn't have reliable 3G or 4G connection, then you could use an IIoT system to send messages out to a sign, which would say you need to take a precaution. Maybe there's a bridge out or something and you want to push the signage control out there. Flood management is important. We talked a bit about water. Many times we'll hear about a city or a town or a municipality being responsible for their own infrastructure. And in that case, the owner and operator of the IIoT system would be the city manager, the city operations manager. And then, we talked about rail and chemical plants that are in a far-flung area. And then also intelligent transport systems, to the extent that we can help with traffic flow. IIoT users can deploy IIoT systems for traffic flow, much like the rail application we talked about before. So just a brief advertisement on Cambium Networks. We have, if you think back to what I've talked about here, which is the flow from the back of that sensor through the data transport back up through to the analytics. The transport can take many different forms, and to that end we have several different pieces of technology and products that can be used in this space. So I'll give you a couple of highlights. On the left there you've got a licensed microwave product, and think in terms of gigabits per second, so lots and lots of data that can be moved with a licensed microwave. We have a backhaul product that can deliver just point A to point B, might be a couple hundred megabits per second, but can do this in a near line of sight environment. We have our access layer, which is a PMP450i product right there in the middle. This is typically used for video surveillance. So if I'm going to put a bunch of video cameras in an area, or aggregating a bunch of data into that common hub. Wi-Fi access, I mentioned Wi-Fi access before. This becomes important as an overlay to IIoT and the ability to provide Wi-Fi to the field technicians that are working on these systems. And then I gave you many examples of See and Reach, which is our narrowband process control and monitoring application. And this is a really closest to the core of what we think about when we think about IIoT, is being able to do machine-to-machine connectivity and do that process control and monitoring. So the things that are important when you build a system, a wireless system for process control, I would just hit these at a high level, but you need to have flexibility. Remember I mentioned that you don't know exactly where these locations are going to be ahead of time. So you need a system that can operate in different ways, whether it's point-to-point, point-to-multipoint, in a very harsh environment, in a point-to-point or point-to-multipoint, or depending on what frequency you want to use, you might have access to different spectrum or different channels to use. And then reliability is important. These are oftentimes going in very rugged areas, very remote areas, so reliability is important. Oftentimes these are in an area where it will take, you might actually have to take a helicopter to get access to the location where the machine is, perhaps during rough weather or the winter, so you definitely don't want these this equipment itself breaking. Also, it's managing mission critical infrastructure, so it's got to be very reliable. Low power consumption. Again, oftentimes these are located in areas where there's not a lot of power, so you have to bring your own power through solar panels and batteries. So keeping the power consumption low is important. And then, as I mentioned, the scalability is important because you've just got so many different devices that you need to connect to the network. So you need a system that will scale up to large numbers of devices. And then security, I talked about that in the cybersecurity aspect. That becomes very important in the IIoT, and that's probably what you read most about IoT or IIoT in the press these days, is about how do we prevent cybersecurity and how do we close vulnerabilities and prevent attacks on the IIoT. And part of being secure is being manageable. So if I can manage what's happening in my network, if I can see what's changing, if I can see that somebody's on the network that shouldn't be, I see that the amount of data that's being used go up or down, that's a good way of securing the network beyond the basics. So that's another important aspect. I did have a couple other thoughts. These are a couple of additional recommended reading. These are a couple of books I read recently that I think if you're just getting interested or just getting involved in the industrial IoT, these would be a great start. It gives you a sense of the breadth of the change that's coming with IoT. We're just at the very tip of the spear here with the IoT. On the left, you'll see the Fourth Industrial Revolution. This was written by the founder of the World Economic Forum, and this is a nice book that covers, they basically polled a lot of industry leaders on when they think certain activities or certain revolutions will happen with IIoT. So things like autonomous cars and even some of the healthcare things that are going to change, but certainly the efficiency and changes in the industrial IoT are covered in depth here. So really a good cross-section overview of where things are headed. And then the other one on the right here by Thomas Friedman is talking about really not only are we at the tip of the spear, but things are accelerating. So not only are we seeing the impact of putting sensors everywhere and putting processing power in every device, we're only just now seeing the impact that that's going to have on the economy in general and individuals and humans as this takes off. It really is going to be a major change, and both of these books will give you a good sense of where that's going. If you want to follow more or hear more about Cambium, we have a lot of ways to stay in touch. We have the LinkedIn, Facebook, Twitter, so certainly those are great resources. But I'd really recommend that you also take a look at our community. Many of you probably are already on the community, but you can either ask more questions about this topic tonight, or you can ask questions of any topic, and you can learn more about the products and the applications that people are using these products. There's a whole section on there about industrial IoT, so you can go on there and read some more. So that pretty much wraps up the session for today. If there's any questions, go ahead and fire away, and otherwise, Colin, I'll hand it over back to you.
Okay, great. Thanks, Bruce. It was a great presentation. And so, yeah, I'll just stall for a few more minutes. I'll let you guys type up any last-minute questions you might have. You kind of stole my spot in talking about the community, but that's okay. We have obviously been...
Tell us, yeah, go ahead and tell us more, Colin.
Obviously, we've been recording this session here as we do every week, and we'll post it to YouTube and then post that YouTube link onto our community. If you watch it on YouTube, we won't see any comments you make, but if you do watch it in the community version, we will, and we will get back to you there. And we have Bruce and all the other product managers, we have them check their section at least like once a day or so. So there generally is some timely responses as well. And so there still aren't any questions, so that's okay. Well, that means you did a good job then, Bruce, huh?
All right. Very good.
All right. Well, thank you so much for the presentation. Thank you, everyone, for joining and giving us your time. I will see you guys in 2 weeks for our next session. Thank you. Bye.